Okay, so compressed air, your low-hanging fruit. This is me. I'm Sean Connolly. I'm a CEO of VPInstruments UK. I've got 22 years experience in the industry and in servicing, maintenance, sales, designing compressed air systems and projects and auditing. We'll move on to the next slide. How does this make you feel? Have you ever come home from a nice holiday, finding out that someone has forgot to turn your lights off, close a water tap? How does that make you feel? VPInstruments offers easy insight into energy flows, helping manufacturing plants worldwide to save energy in compressed air as well as other utilities. Let's carry on and show you how to do this. We'll look at this slide here. We're all very aware now of the rise in energy costs in global energy. This graph shows you just how much the global energy costs have gone up in the last year, and we all know they're still rising. The next slide, I think a few of you may know this, compressed air is responsible for 45% of the global energy consumption. This makes compressed air one of the largest energy saving opportunities within our industry. Let's put that into perspective. 45% or 233 terawatts an hour requires 55 600 megawatt coal-fired power plants, over 1,350 megawatt solar power plants, and over 44,000 2 megawatt wind turbines. Why compressed air? In the UK, we refer to compressed air as the fourth utility within our factories. Compressed air can cost up to 8 to 10 times the cost of electricity to generate. In the past, compressed air was understood by engineers and users, but I think this is changing due to the rise in energy costs. And obviously, we feel compressed air holds many low-fruit energy saving opportunities. Move on to the next slide here. We've got the cost of compressed air, which, as we said earlier there, 8 to 10 times more than electricity. On average, 20 to 30% pence per meters cubed to produced. And where does all of that go? Well, approximately 85% goes into generating wasted heat, and the remaining 15% goes into producing the compressed air. Up to 50% of the air generated in UK factories can be wasted through leaks, artificial demand, and of course, inappropriate use. On to the next slide. Low-hanging fruit, where are they in your factory? The fact here, compressed air plant energy costs more than 75% of your total energy costs over a 10-year life cycle period will be in energy, and that is a fact. Obviously, the rest of that will be purchases, the capital purchase of the plant to start with, and obviously routine maintenance costs and breakdowns, etc. What we're looking at here is, instead of buying a new compressor, thinking about improving your compressed air system first. How can we save it? There are many ways to save energy within a compressed air system. You can look at VFD or VSD drive compressors. You can look at heat recovery, optimizing your control system, overall system design, reducing the pressure on site, optimizing dry air receivers in your system, look at eliminating pressure losses, and of course looking at air leaks. In the UK, I know we said up to 50% earlier, but a typical site can easily be between 10 to 30% leakage rates, which is obviously quite high. Move on to the next slide here. Obviously, this is our product range. You've got measure, discover, and save. To help you identify the compressed air savings potential on your site, you'll need to do a survey, an audit, and measure the compressed air system. Move on to the next slide here. Take the first step. How much does it cost to invest? I think this is always a little bit, people think you have to spend thousands and thousands of pounds on flow meter and equipment. You don't have to. We look at this site here, we've got 3 compressors. You've got 125 kilowatt, a 75 kilowatt, and a 37, all running different hours throughout the year. The total cost of the energy bill for this site was £187,000 a year to run. We know that there's 10 to 40% cost savings possible. And let's look at a 5% investment, a budget to phase 1 of sort of auditing this plant. If we look at basic flow meters and a basic monitoring system and the data logger, the total outlay would be around about 9k. That would be for a couple of flow meters and to start your auditing process. So let's look at that 5% savings on this site, anywhere between 18k and 75k. So an initial investment of 9k is really worth looking at. These figures actually are based on 20 pence per kilowatt hour. There's a few sites I've been to in the UK over the last 12 months that are still paying around about 13 to 16 pence a kilowatt hour. I heard last week a company had just been put up to 19 pence. But I think, as most of us know, there are sites in the UK that are paying 30 pence or more per kilowatt hour in the UK. Start small, dream big. I think, we said earlier, VP, you don't have to invest a huge amount of money or into a complete system from day one. To look at your opportunities on sites or at your customer sites, you can just start with 1 flow meter to start the auditing and process. Let's move on to a case study here. This case study is in Germany, a German cocoa factory. As we can see here just on the slide, the efficiency increase was from 7.36 to 5.83 kilowatts per meters cubed. The leakage volume on this site was 50%. The savings potential on this site was £107,000. Obviously, after sorting this out, the increase in production by solving leaks and machines improved. So these sort of sites here are really worth looking at. And I think what we look at here as well is that people think what they're getting isn't what they're actually getting. That's when we move on to the value of measuring and monitoring. Why do we do it? We want to keep a constant eye on consumption. We want to detect leakage and wasted downtime on sites. We want to benchmark multiple machines and sites, optimize service intervals and maintenance schedules. We want to allocate costs to production processes. We want to understand the impact of new production equipment on the compressed air system. We want to be able to troubleshoot and diagnose problems. We want to start trending KPIs on site. And we want to look for data for investment decisions and look at real returns on investment. Move on to the next slide here. This is just a typical image of a plant room. Got a couple of compressors, dryers, receivers, filters, and obviously there's a few flow meters in there as well. What can we use them for in here? We can look at efficiency monitoring on the compressors itself. We can do air audits and leakage management within the plant room, and we can also look at cost allocation. Move on to the factory floor. The value of look at point of use measurement. We can look at auditing pressure losses, and look at the total system itself. Move on to another case study here. This is a predictive maintenance site. There's 1,000 filter bags on site. I've been involved with a site recently on a flour mill where they're having issues with their bags splitting and everything. This site had 1,000 filter bags, 1 pulse per minute to clean the filters. The specifications of this of the equipment was 750 to 850 meters cubed an hour on average. After the auditing was carried out, the actual findings were 1,100 to 1,500 meters cubed actual consumption. This means, you know, this was having issues on site. Filters weren't being cleaned properly and were getting filled up and clogged, and obviously had an impact on production. Savings on this site were between 14 and 24k. Once the flow meters were installed, the site were obviously able to check and monitor the issues on these filter bags. Let's move on to the next slide. This was the specific power on this site at the time. It's 130 watt hours per meters cubed. The kilowatt price at the time was 4 pence a kilowatt hour, so it's a while ago. The leakage was approximately 540 meters cubed an hour, which equates to about 70 kilowatts in compressed air energy. Based on 5,000 hours running and 8,000 hours running, the savings were 14 to 24k. Why permanent monitoring? You know, a lot of people say, why do you need it? Because permanent monitoring can help you to maintain these savings. As you can see in the graph, any consumption tends to rise over time. You can fix one leak, then another leak appears a week, 2 weeks later. And this continues throughout the production processes. An audit will help you establish savings, but after the audit, things can also turn bad. Again, after a while, as I said, leaks will find a way of coming through on production equipment, hoses, couplings, etc. With permanent monitoring, the energy consumption be kept at the lowest level possible. As a monitoring system, this will always also give you continuous feedback. How to monitor a system. If we look at, this is a an ID drawing of a plant room, typical plant room. So we can look at measuring the power of the compressor. So we can use our VP loggy range or our 3-phase power meters, flow meters, and dew point sensors. And let's not forget here, you know, you don't need extra pressure transducers, because our VP flow scopes measure flow pressure and temperature from one device, and also have a meters cube totalizer built in. We look at some energy management reports here. Obviously I missed on the last slide there, obviously looking at connecting the VP Vision in as well. What can a VP Vision monitoring system give you? Now, with today's energy costs, it is helpful to have a report. This is an example of a report that's from our VP Vision monitoring system. If you're going to the expense of installing flow meters, fixing leaks, etc., you want to be able to collect that data, yeah, in as many ways as possible that are helpful to you. You know, and the other thing here is as well, if you've got a building management system, or you're just doing the login every now and then, you know, there's a lot of time and energy and manpower going into sort of generating those reports. You know, with the VP Vision, these reports can be monitored to you daily, weekly, or monthly with your key KPI figures, all there ready to see. We look at remote energy monitoring as well with VP Vision. You've got continuous access anytime, anywhere, even during COVID events. If you're off sick, if you're on holiday, you can basically dial in and see what your compressed air plant is doing. It's safe, secure, dedicated connections. We can look at VPN connections, 3G or through 4G networks. We can also look at multiple sites. Obviously, today is 2022. You can have a lot of sites sometimes don't like connections into their main systems, but today it's safe and secure. You can have a dedicated connection with no effect on your system at all. Moving to another case study here. This is a company called IO Glass, which I think a few of you may have heard. It's one of the largest glass companies, manufacturing companies in the world. Oh, I think I've just dropped off there. Right, let's look at this site here. Common issues: leakage on machines, and it was causing downtime. Compressor inlet filters were having issues. There was pressure fluctuations in the plant room and across the site. What did they do here? They obviously carried out an audit. This was with one of our distributor partners, Stork. They identified where the flow meters needed to be and installed VP Vision, 20 flow meters. The flow meters helped as inputs for the controls on their system. They installed a booster pump and emergency valves between the site's low pressure and high pressure networks, and they installed a master controller to control all the compressors and compressed air plant. So the savings on this site was 240k, which is obviously a lot of money. Move on to the next slide. How do we start? You know, you want to decide on your main KPIs, define your goals. How do you start the process? You need to collect the data and understand, you know, what your system is doing. So we look at efficiency. You want to measure the airflow at the main header, and you also want to measure the power consumption, and that's on the wet side of the system. You want to look at the leakage rate, the leakage flow, the average flow, and any events that happen on the compressed air plant. And you want to know the total amount of compressed air that's being used, and obviously, you know, production output. You know, what's actually happening. You know, what you do need to know is you need to understand the generation side and the demand side of your compressed air system. And talking to a lot of people in our industry, especially some sales guys, they sometimes find it hard to understand why they've got 500 CFM being generated on the wet side and only 300-400 CFM going into the factory. You know, compressed air flow meters help you understand that and show you the real, let's say, the real flow into your factory and how much air is actually being used. Move on to the next slide here. Obviously, you need to perform an initial audit to identify the current state of your system. And going back there, what we said, compressors, you want to know the compressor's kilowatts, the compressed air consumption, pressure, temperature, dry side, main header, pressure downstream, problem areas and consumers. You know, and you know, once the auditing equipment is fitted, why don't you leave it installed? So we've got to look at, you know, you need to analyze these audit results. You know, what are the three top issues? You need to identify those. You need to identify what is the savings potential. And you also need to know how can you maintain those savings and the return on the investment for yourself and the customer. So obviously we say install permanent monitoring equipment in a system, you know, to maximize and maintain your energy savings. You know, you can leave your audit equipment and sensors in place after you've carried it out. You can install monitoring software and hardware. You can configure alarms, KPIs, and make them available with VP Vision. And you can expand to other areas based on the facts generated and your return on investment. VP Instruments production lines. What do we sell? What do we promote? What can you buy? We do VP flow scopes, as we call them. We do inlines and probes. We do them bi-directional flow, pressure, temperature, and total flow. It's obviously a totalizer. We do power meters, single phase and 3-phase power meters, and dew point sensors. On the energy management and predictive maintenance side, we do our VP Vision, which is a complete energy monitoring system. This can be used for compressed air, but also other utilities on site and sensors. It will take a 4 to 20 milliamp or pulsed input. It will take Modbus RS485, and it will also take Modbus Ethernet RS485 TCP. Service installation is a service we offer in the UK, but you can buy the equipment off of us as well. You can buy specialist hot tapping equipment and service and equipment for that as well. Systems approach for energy savings and improve systems performance. So where we offer the complete system approach, we want to help you to save energy and improve the efficiency of your plant. We can offer you the tools to do that. If it starts with your plant, you need to measure it. You need to measure it with sensors, and those sensors gather data, and we can use that from basically the data logging heads on the flow meters or from our VP Vision system. Okay. This provides you insight upon which you can make your decisions for optimization, so you can make fact-based improvements and look at your return on investment. Conclusions: why measure and monitor? You need to get to know your baseline and your fingerprint of your factory. You can look at permanent monitoring is the key to continuous savings. If you take the auditing equipment out and only have it done once a year, you're not really getting a real handle on how much you can save. It's all about people and behavioural change. I think people are changing now with the rising energy costs, and people are really looking at ways of saving energy. And as a fourth utility, compressed air is essential to your plant, but also what we feel is the highest energy saving potential out of all of those utilities. You can set the right KPIs and management policies in place. You can take it step by step, fund the next step from your savings. You don't have to, you don't have to have a huge capital outlay to start with, and buy 1 or 2 flow meters, and then identify those savings, and then fund the next step with those. So start now. Data is the key. Invest in an efficient plant and a better future. And there we go. They've gone through that quite quickly today. Thank you.